Assembler language instructions. In this video, you'll learn about many of these assembler instructions. Some of them you'll use in your job, some of them you won't. But you'll need to recognize them so that you know when you should use them, and so that you can interpret assembler programs that other people write. In this video, we want to help you organize these instructions in your mind. We'll categorize them by what they do, and we'll look at some examples of each type. Here are the categories of instruction types. You'll see instructions to move data, calculate or perform arithmetic with it, convert it from one internal format to another, compare data, branch to other program instructions, and change data at the bit level. Let's look at the first type of instruction. Sometimes you'll want to move data from one main storage location to another. For example, you might want to perform an operation on a field in an input record, and therefore will want to move this record to a work area. You need a move characters instruction to do this. Work field and input field are data names. They're the operands in this instruction. This instruction moves the contents of input field into work field. There are different kinds of move instructions. Don't worry about them now. You'll learn how to use them to move large and small amounts of data, or to set areas of main storage to one value. Sometimes you'll want to use a register in the CPU. A register is a special area of storage in the CPU. It's fast, and it can be handy to use for certain operations. A register holds 32 bits, or one word of binary data. You have access to 16 general-purpose registers. You can use some of the different move instructions to get data into and out of the registers. Let's say that the data in work field is a full word in binary format, and that you want to put it into register 7 to work with it. This instruction does that for you. L is for load. The contents of the full word at the location named work field are loaded into register 7 for you to work with it. You can load multiple registers at one time. LM stands for load multiple. If you had 3 words of binary data starting at work field, and you wanted to load them into 3 consecutive registers, you could use a load multiple instruction. The 3 adjacent words of data go into the registers specified in the instruction. Another instruction lets you move data from one register to another. Load register. The contents of register 7 go into register 6, replacing whatever was there. Do you want to move data from a register to main storage? The store instruction lets you do that. It stores the contents of register 6 into a word at work field, replacing whatever was there. We call the area where the data comes from, register 6 in this case, the source or sending field. We call the area where the data goes to, work field, the target or receiving field. You can store multiple registers with one instruction. Store multiple. Here, the contents of 3 registers go into 3 words of adjacent main storage, starting at the location named work field. What move instructions do we have so far? The first type of instruction lets you move data between locations in main storage, between main storage and registers, and between registers. A second type of instruction lets you calculate or perform arithmetic on your data. Let's say that work field 1 has this value, and that work field 2 has this one. They're both in packed decimal format. This instruction is add packed. It takes the contents of work field 2 and adds them to the contents of work field 1. The contents of work field 2 do not change, but the sum of the numbers is now in work field 1. There are similar instructions to subtract, instructions to multiply, and instructions to divide packed decimal numbers. We won't show you how they work now. You'll learn about them in detail later. How about arithmetic with binary numbers? This instruction adds the contents of two registers. For example, if registers 6 and 7 both contain binary numbers, this instruction adds them together and puts the result into register 6, replacing what was there. You could also add a binary number from a location in main storage to a register. The result goes into the register. The subtract instruction works in a similar way. The value in work field 3 is subtracted from register 6, giving this result. You can calculate with binary numbers in registers or using a register and main storage. Like decimal arithmetic, there are instructions that subtract binary numbers, multiply them, and divide them. The third type of instruction we'll look at lets you convert data from one format to another. Why would you want to do that? Sometimes the data your program reads is in zone decimal format. In assembler language programs, you have to convert that data into a packed decimal format in order to do decimal arithmetic on it. One of the instructions to convert data is a pack instruction. This instruction doesn't just move data from that field in the input record to the work field. It converts it into packed decimal format. Then you can use decimal arithmetic instructions to work with it. When you're through operating on work field and are ready to write it out, you'd use the unpack instruction to convert it back to zone decimal. The pack and unpack instructions convert zone decimal numbers to packed decimal and back again. There will also be times when you need to convert a number from a packed decimal format into binary format, perhaps to work with it in registers. Convert to binary will do that for you. This instruction requires an 8-byte packed decimal source field. Suppose the work field looks like this. If you want to put it into register 6 in binary format, this instruction will do that for you. Do you want to convert that binary number in register 6 back to decimal? Here you would use convert to decimal. This instruction stores the value from the register back into work field again in packed decimal format. The convert to decimal instruction requires that the receiving field be 8 bytes long. The conversion instructions zoned to packed, packed to zoned, decimal to binary, and binary to decimal let you switch data from one numeric format to another. You've seen that there are instructions to let you move data, do arithmetic on it, and convert data formats. What's next? Comparing data. Why compare data in your program? Suppose you want to see if two fields are equal, and if they are, branch to a certain place in your program. You need instructions to let you compare two fields. This is compare logical characters. It looks at each byte of work field 1 and compares it to the corresponding byte of work field 2. Depending on what it finds, it sets a condition code. A condition code is a temporary internal indicator that you can test with certain instructions. When the compare logical characters instruction compares two fields and finds them equal, the instruction sets the condition code to 0. If the first field is lower, the condition code is 1. If it's higher, the condition code is 2. This instruction compares register 6 to register 7 in a similar way. Register 6 has a higher value, so the condition code is 2. There are other compare instructions for other situations, such as compare, which compares a register to a full word of storage. Compare half word, which compares a register to a half word of storage. And compare logical immediate, which compares a single byte of storage to a byte within the instruction. But now what? We've compared work field 1 and work field 2, and we know we want to branch to certain places in our program based on the results of the compare. That involves the fifth type of instruction we want to look at, the branching instructions. This instruction, branch on equal, takes us to a location called do more if the compare we just did turned out equal. How does it work? The branch on equal instruction checks the condition code to see if it is 0. Since work field 1 and work field 2 are the same, the program now branches to the location do more and executes whatever instructions are there. If the two fields are not equal, the condition code is not 0 and no branch takes place. Execution goes to the next instruction. There are a variety of branching instructions. This instruction is an unconditional branch. It branches no matter what. Other branching instructions combine conditional tests and a branch. One example is the branch on count. There's one more type of instruction we want to look at. This type lets you change or manipulate data fields and register contents at the bit level. Bit level changes are very important in assembler language. Sometimes you'll want to shift the contents of a register. For example, suppose you want to shift the contents of register 6 one bit position to the left. We'll look at the register contents in binary, bit by bit, instead of in hexadecimal. This instruction, shift left logical, shifts each bit in the register one position to the left. The rightmost bit becomes 0. Using 2 as an operand, shifts the contents of the register 2 positions. Besides shifting bits, you can also change individual bits in a register or in a main storage location. If register 6 has this bit set on, that is, equal to 1, and register 7 has this 1 bit set on, then this instruction does what's called a logical OR. It looks at both registers, and if a bit is on in either register, the instruction sets that corresponding bit to on in the result location. The result is in the first operand, register 6. So the result shows 2 bits set in register 6. If work field 1 and work field 2 contain similar values, this instruction, OR characters, would work the logical OR on them. Like the other instruction types you've seen, there are a variety of instructions of this changing or manipulation type. They let you do things such as ensure a sign code is present or zero out a field. 6 types of instructions, therefore, give you all the tools you need to program successfully in assembler language. All of the instructions you learn will be one of these types. Please turn to Mini Course 4 in your PRG and complete exercise 4.1.